Here we go with number 10. The first term of an infinite geometric sequence is 2. Whenever you're doing a problem and you don't know what it says, stop. Think about it word for word. The first term is going to be a list. Infinite, I'm going to be writing a long time. Geometric, we're multiplying. Sequence, it's a sequence, and it is 2. So basically it's going to be 2, comma, something, comma, something, comma, something, comma, something. And to get these somethings, I'm multiplying by the same thing every time. And it goes on forever. The sum of the sequence is 6. If I was to add all of these together forever, I would get 6. Yes, that's possible. What is the common ratio of the sequence? Let's think about this in terms of things that were said in class. Because it is an infinite sequence and it has a sum, I do know something that's actually going to eliminate 2 choices right now. I'm going to write this out in words. Because it is an infinite sequence with a sum. I'm adding together an infinite number of things and I get a sum. R is less than 1. Now, to be fair and to be mathematically realistic, what it really means is R is between 1 and negative 1. But since all the answer choices are positive, we can just stick with this. And real quick, let me explain what that means. I'm going to grab a scrap piece of paper and I'm just going to ramble for just a second. I've got some blue paper. Here goes. Basically, if I was to multiply by a number that is less than 1 every time, I'm going to pick a random number like a half. Okay? If I multiply by a random number like a half every time, half of 2, half of 1, half of that, and I can keep on going forever. And if I add those up, it'll come up to be just a regular number. It'll equal something. It will equal, I think the answer to this one is 4. I might be mistaken, but I'm pretty sure the answer is 4. Yeah, it's 4. I can add that up and I'll get an answer. Like if I was to have 2 sheets of paper and then 1 sheet of paper, then a half sheet of paper and a fourth of a sheet of paper and an eighth of a sheet of paper, if I was to do this forever till the end of time, all the way to infinity as if we could, you'd have 4 sheets of paper. You got 3 counted right here and then you got a whole bunch more that constitute 1 piece of paper. Okay? And if R, our common ratio, was greater than 1, I'm just going to make up a number. I'm just going to pick a 3 because I feel like it. If we were to triple it every time, then it's going to get a little complicated. And if we were to add them together, we were to add all the stuff together like we did on the last one, and add all these together, we're going to have 2 plus 6 plus 18 plus 54 plus blah, 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 blah. Whoa, 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 whoa. Yeah, that becomes infinity. So that's why I said this. I just wanted to address that again real quick. Because it's an infinite sequence with a sum, R has to be less than 1 or greater than negative 1. It's between negative 1 and 1. So let's go ahead and eliminate a couple answer choices. Which ones do you want to eliminate? Boy, I hope you're looking at the same ones I'm looking at. There we go. That actually obviously is 1, and that one is 4/3, which is greater than 1. So it's either A or B. So now the question is, well, how do we find it? The sum of the sequence of what? An infinite geometric sequence. There's a formula for that, and here is the formula. The sum of an infinite geometric sequence is equal to first term divided by 1 minus R. There's a beautiful way algebraically to show how this comes to be and why this formula works, but we're not really going to go there right now. So what we're going to do is take this formula and plug in everything we know. Let's read the problem one more time. First term of an infinite geometric sequence is 2. 2. The first one is 2. 2 equals, 2 over that equals something. The sum of the sequence is 6. 6. Goes right there. The sum is 6. What is the common ratio? They're asking for R. Solve that. That's all it's asking you to do. So let's solve that. Let's put it over 1. Let's cross multiply. 1 times 2 is 2 equals 6 times 1 minus R. So 2 equals 6 minus 6R. We subtract 6. doing some stuff in my head. We will divide by -6. I'm assuming you can see the answer at this point. I'm going kind of fast. -4 over -6 reduces to be +2/3. The answer is B.